All right, let's go ahead and get started with Chapter 4, Lesson 5, Direct Variation. So the objective for today is to identify, write, and graph direct variations. So let's go ahead and get started. So a direct variation is a special type of linear relationship that can be written in the form of y equals kx. So this is just a special type of linear equation. And what I want you to know is, what did we talk about last section? We talked about slope-intercept form. And what we have is y equals mx plus b, right? So this is a direct variation, y equals kx, but we're going to kind of compare the two because this direct variation is a special type. Now let's talk about why it's so special. So what do we notice? Y is the same, equals is the same, and then we have mx and a kx. Well, this k is different. This k is a non-zero constant called the constant of variation. So the k here is called the constant of variation. But what I need you to understand is that the constant of variation is really the same thing as the slope. So constant of variation is the same thing as the slope. So what that means is k is the same thing as m, which means everything you know about m, which is the rise over the run, and it's the change in y over the change in x, and we're talking about rate of change and all that type of stuff. All of that knowledge you already have about the slope, that applies to the k. So whenever you see this number in front of the x, you know that that number is the slope. But with direct variations, there's special types of linear relationships. So they have that, they give it another letter and they call it a k for constant of variation. But what I need you to understand is that k in front of the x is actually the same thing as the slope. So, and then the equation y equals kx describes a relationship where the dependent variable, this is really super important, the dependent variable, or dependent value, right? And these are super important words, varies directly with the independent value. Otherwise, what this means is that the dependent value, what's the dependent value? It's y, varies directly with the independent value, which is x. So y varies directly with x. And this is super important, really more for when we get into application problems, but whenever you see those words varies directly, you should there should be like a flashing light that's going off and whoa, I know that I'm dealing with a direct variation, which means I can write down the equation y equals kx whenever you see those words varies directly. Whatever comes in front of the words varies directly, that's referring to the y, and whatever comes after the words varies directly is referring to the x, or the independent variable, okay? So this is super important. You have to commit this to memory as well as this. So remember, when we are talking about this direct variation equation, it's very similar to slope-intercept form that we just talked about. The k and the slope is the same thing. But what else is different? Oh, slope-intercept form has this plus b, right? Which meant it could be any number. What's happening with the direct variation? There is nothing here. But oh wait, when there's nothing there, that actually means something. There is a y-intercept, but when that y-intercept, there's nothing there, that means that the y-intercept is 0. This means for all direct variations, this is super key, for all direct variation problems, and this is why they're special, or one of the reasons why they're special. For all direct variation, the y-intercept is equal to 0, which means since it's equal to 0, right, it's equal to 0. This is the y-intercept. That means that for every direct variation, they always go through the origin. So there's that characteristic, and then the second characteristic is every direct variation equation passes through the origin. So since it passes through the origin, you know, right? So for any line that passes through the origin, you know that the y-intercept is 0, but you also know that the x-intercept is 0. And really any line, so if it's something like this, and it goes through the origin, direct variation. Any line, we can draw any line. I'm gonna draw really like this. It goes through the origin, direct variation. Any line at all, it goes through the origin. Guess what it is? You guessed it, it's a direct variation. Any line, we're gonna go here. Oh, it goes through the origin. Guess what it is? It's a direct variation. One more right here. It goes through the origin, it's a direct variation. And you know that that y-intercept is 0, but you also know that because it goes through the origin, the x-intercept is also 0. So let's go ahead and look at some different problems. Okay, so 1A, what are we doing with this problem? It says identifying direct variations from equations. So we're just going to basically tell whether the equation represents a direct variation. If so, identify the constant of variation. All right, cool, let's do it. So we know for this to be a direct variation, it needs to be in the form y equals kx, right? It's solved for y, and all there is this kx, and that's it. And this looks like it totally matches up. So this is, yes, a direct variation. And then we just have to figure out what the constant is. And the constant of variation is just the number in front of x, which is 3. So k equals 3. So that is our answer. All right, let's look at the next one, 1b. It says tell whether the equation represents a direct variation. If so, identify the constant of variation. All right, cool. So we are finding to see if it's a direct variation, y equals kx, right? That means y needs to be by itself. Is y by itself? No, it's not. So we need to make y by itself. So we're going to get rid of this 3x by doing the inverse operations. And we end up with, we're going to write that x first. Is this a direct variation? No, it is not, because we have a y-intercept of 8, and for every single direct variation, the y-intercept has to be, yes, it has to be 0. So up here, right, y equals 3x. There was nothing there, which meant that the y-intercept is 0, so therefore we know it's a direct variation. Over here, the y-intercept isn't 0, it's 8, right? Because the slope-intercept form tells us y equals mx plus b. This is the y-intercept. The y-intercept's 8, it needs to be 0, not a direct variation. So we just say not a direct variation. Okay. Let's look at another example. So example 1c here. Okay, so we're just going to tell whether it's a direct variation. We have an equation in standard form again, so we have to put it into direct variation, which means y equals kx. We need to isolate that y and get it by itself. So I'm going to start by moving this 4x to the other side. 3y equals 4x, and then this is like plus 0, but I don't need to write that, right? We don't need to write plus 0, so we'll just leave it blank, which means that it is 0. Then we need to get y by itself, so we're going to divide by everything by 3, which means we end up with y equals 4/3 x. Now, is this a direct variation? Is this in the form y equals kx? Is there y-intercept 0? Yes, there's nothing here. That means the y-intercept 0. This is perfect. This is direct variation. So yes, direct variation. And then we just need to say what our k is. And k is equal to the number in front of x, which is a fraction, and that's totally okay because it's the slope, right? It's the rise over the run. So there we go. There is our, yes, this is a direct variation, and the constant of variation is 4/3. Perfect. Now it's time for you to try some of these on your own. So I want you to check it out, example 1A. Go ahead and pause your device. When you get done, press play and we'll go over it together. All right, see you in a bit. Okay, let's see how you did. We're going to tell whether this is a direct variation, y equals kx. So we need to solve and get it. We need to get y by itself. Is y by itself? No, it's not. So we're going to divide every little thing by 3. Okay, that ends up being y equals 4/3 x plus 1/3. And for direct variations, the y-intercept needs to be 0. We know that this is in slope-intercept form as well when it's solved for y, and the y-intercept is 1/3, so we know it's not a direct variation. So not a direct variation. All right, perfect. Okay, let's look at the next example. So here we have check it out example 1b and check it out example 1c. So I want you to go ahead and solve both of those on your own. And here's my friend the pause dragon. Remind you to pause your device. When you get done, press play and we'll talk about the answers together. All right, see you in a bit. Okay, let's see how you did on 1b. So we want to figure out if this is a direct variation, which means we have to solve it for y. We got to put it in y equals kx, right? So to do that, I'm going to get rid of this -4. This is -4 times y. So I'm going to do the inverse operation of multiplication, which would be division. I'm going to divide both sides by -4. That means I end up with -4 3/4 x equaling a negative divided by a negative is a positive. 4 divided by 4 is 1. 1 times y is y. So now y is by itself, but I'm going to go ahead and swap sides. So I have it y equals -3/4 x. And we have it in direct variation, right? There's nothing, no number here, which means our y-intercept is 0. This is perfect. So we know that this is a direct variation. So yes, direct variation, and then we just need to say what that constant of variation is, which is the same thing as the slope, right? Which is just this number in front of the x. So k equals -3/4. So if you got that one right, amazing work. Okay, let's see how you did on the next one. So again, we need to get this in direct variation form, which means y is by itself. So we get, right now, y is not by itself. So we have to get y by itself. So we're going to subtract 3x to both sides. We end up with y equals -3x. We always want to put that x first, plus 0, and we're not going to write plus 0. So this is it. And this is in direct variation. So we're going to say, yes, a direct variation. The y-intercept is 0, which is perfect. And then we just need to say what that constant of variation is. And it's just this number in front of the x, which equals -3. So if you got that one right, yokorikimashita, you did a wonderful job. And I'll see you in a little bit for example 2.